Good morning, viewer. Welcome to today's data handling lesson. We're going to focus on grade 12 content. My name is Mr. Khadle Mapolo. As I say, I'm going to take you through grade 12 data handling. In grade 11, we learned about univariate data. Grade 10 and 11, from grade 9, we were learning about univariate data. Univariate data is when you only talk about one variable. So now in grade 12, you learn about bivariate data, where we talk about the data involving two variables, where the relationships between them is being analyzed. And then this is used to explore correlations and trends. Just like, for instance, they can give you a table of two things, like when we were exposed to COVID in 2020. There was this theory that when it is cold, when it's very cold, at cold temperatures, number of COVID-19 cases increased. So now you can see that you talk about two things, the temperature versus the number of COVID-19 cases. So if they can say, what is the trend? You say the trend is that as the temperature decreases, the number of COVID-19 increases, or vice versa. So in that case, you talk about two things. That you analyze the relationship between the two things to say what happens to the other when the other one changes. So, like I'm saying, in this topic, we talk about their correlations and trends. So you'll be learning much about the least squares regression line in the next slides, and also learn about correlation coefficient. And don't forget that the symbol for correlation coefficient is R. So correlation coefficient only ranges between -1 and 1. So it means it cannot be greater than 1, it cannot be less than -1. So that is the correlation coefficient. Then you'll learn much about it and how to calculate it in the next slides. Now, suppose you are given the table of two variables where you plot x versus y. So obviously in a table, they say they can give you two columns or two rows, and then one will be the inputs, the other one will be the outputs. So obviously we know that when you plot on the a grid or a graph paper, you'll plot x where the coordinate of x and y in every plot. So if you plot them like this, you may be asked the strength of the correlation. So I think there's a clear correlation here. You see that it's a straight line when it's a, if not almost a straight line. If you check in this case, there is that trend that as x increases, y increases. But now, if you are asked to determine the strength of the relationship, or the strength of the correlation, it will be determined by how the plots will be closer to the line called the best fit line, or the least squares regression line. Like, for instance, if I draw the line, you see that all the plots will be on the line. So if you are required to determine the correlation, you'll say there's a perfect positive correlation. But now, it does not mean that if you don't have a scatter plot, and then you don't have the least squares regression line, then you cannot determine the strength of the correlation. So you use a calculator. That is something that I'm going to show in the next slides. If you find that R is 1, then the comment would be that there's a perfect positive correlation. Same applies. You can see that in this case, the plots are there, and then you can see that as x increases, or as the variable on the x-axis increases, or as the variable on the horizontal axis increase, and the variables on the y-axis will also will decrease, or vice versa. You can see that there's a negative gradient. So if you see, if I draw the line like this, all the plots will be on the line. So if one can say, comment on the correlation, you will see there's a perfect negative correlation. So, but if you are just given the table, you will calculate. If R is -1, then you will say there is a perfect negative correlation. Now, sometimes you may find that when you draw the scatter plot, you can see that this line, they are not in a straight line, but they're closer. And then you can see that it still fits the straight line, even if all the plots will not be on the line, but there's that upward trend. There is that the direct relationship to say when the variable on the horizontal axis increases, the variable on the variables, also or all the as the values on the horizontal axis increase, the values on the vertical axis will also increase. But now, unlike the first one, if you check this one, if you draw the line of the best fit, or least squares regression line, which I'm going to show you how to sketch it in the coming slides. So you can see that some plots are on the line, but others are not on the line, but closer. So if you don't have a scattered plot, but you have only the table, you'll calculate the R. If R is between 0.5 and 1, then you'll say there's a strong positive correlation. And if R is very closer to 1, like 0.98, you can say very strong positive correlation. But I don't think you can lose marks if you don't add the word very. But you see that it's closer to 1. All the plots are not on the line, but they're very closer to the line. So in this case, there's a strong positive correlation. And then to determine that, you use a calculator. And if R is any number between, even it can be 0.7, you say there is strong positive correlation. If you see now, these plots are not that close, but you can still see that as the variable on the horizontal axis increase, the variables on the y or the vertical axis also increase. But the plots are the plots are not closer to each other. So if you check here, if we draw a line, you can see that there are some plots far from the line of the best fit. Then but you can also determine that without scatter plot. If you calculate R and you find that R is 0.5 or any number closer to 0.5, like 0.498, 0.512, just like that, then you'll say there is a moderate positive correlation. So the R will be around 0.5 or 0.5. So if R is there is 0.5, then you'll say there's a moderate positive correlation. Now, in this one, you can see that they are also far apart more than they were in the previous slides. But you can see that there is still the trend that as the variable on the on the horizontal axis increase, and then also the variables on the vertical axis also increase. But the plots are not closer to each other. So if you draw a line, you can see that you have the plots like this, you have the plots like this, but you can see that there is that increasing trend. There's that increasing trend. And but you can see that they are not very close to the least squares regression line. So if you use a calculator and get that R is between 0 to 0.5, then you'll say there is a weak positive correlation. It's a weak positive correlation. Like here, you see that the plots are closer except one. So this there's still strong relation. We will consider this one as an outlier, but most of them are closer to each other. So this one is an outlier. So if one can say what is the strength of the correlation, if you draw the line, you see that most of them are closer to the line except this one. We'll ignore it because it's an outlier. Then we'll say there is strong negative correlation. So meaning that when you calculate R, your answer must be between -1 and negative 0.5. And then if it's very close to -1, like negative 0.97, that will be a very strong negative correlation. But however, you must know that when the correlations between -1, correlation coefficients between -1 and negative 0.5, here it will be less than. When it's between, we'll have to remove this equal sign here. Just say when R is between -1 and negative 0.5. So we'll change this equal sign to be less than. So it means when R is any number between -1 and negative 0.5, or very close to -1. Like -0.98, -0.97, we say it is very strong negative correlation, but if it's any number between -1 and negative 0.5, then we'll say there is strong negative correlation. And even if we have this one does not change the strength because it's an outlier. Most that are closer except. So remember, in grade 11 we learned about outlier when we talk about the value that is out of the ordinary. Remember, almost all of them, they are closer to the line of the best fit, except only this 1 point. This 1 point, we'll ignore it because it's said to be an outlier. So still you can say that x as the variables on the horizontal axis and the variables on the vertical axis also, sorry, when as the variables on the horizontal axis increase, the variable on the vertical axis decrease. So in this case, they are not close to each other, but you can see that there is that decreasing trend. So if you use a calculator, then you get that your R is negative 0.5 or any number closer to negative 0.5, then you'll say there is the moderate. If they ask you about the strength of the correlation, you say there is a moderate negative correlation. You can see that the plots are not very close to the line of the best fit, and then but you still have an outlier. What you're going to consider most here, they are not close, but they are not close to the line of the best fit, but they are not that far. So in this case, remember, I've not drawn this to scale, but remember, you to determine the strength, you don't just look at the scatter plot and say and conclude that there is a moderate negative correlation. I'm just using the scatter plot so that what you understand what we mean by say is moderate. What do we mean by that? But to determine the strength, you'll be calculating using a calculator. Then to determine the R, once you got the R, then you'll be in a position to comment on the correlation. You'll be in a position to comment on the correlation. So in this case, if R is negative 0.5 or any number closer to negative 0.5, then you'll say there is a moderate negative correlation. Like here, you can still see that there's a decreasing trend, but now the plots are far apart from each other. You can see that if you draw a line, so you can see that they are very far. You see, this is very far, this is very far, but you can't say these are outliers. Remember, outlier cannot be many. So if most of them are far, so it means we'll say there's a weak negative correlation. So, but to get that, you have to calculate if R is between negative 0.5 and 0, then you'll say there's a weak negative correlation. But if you check in this one, you don't see that they're widely scattered. You don't see whether there's an increasing trend or decreasing trend. So it means R will be equals to 0. It means in this case, there's no correlation. There's no correlation. Now let's look into that now. Now we're going to learn how to determine the equation of line of the best fit or least squares regression line, which is defined as y equals to a plus bx, and also how to draw the least squares regression line or the line of the best fit, and also to determine the correlation coefficient. Now, if you use a Cashew, then you can determine how the A, B, and R by following the following method. So when you press mode on your calculator, it will give you options. Then you press 2. It will give you options again. Then you press 2. When you press 2, it will give you the two tables for the input and for the output. So you can start with the one on the left with the input. Then you say the number equals to, it will enter that. The next one equals to, then you enter all the scores on the on the left hand side. Then you check the outputs on the table that would if they gave you the table, then you enter the outputs on the right hand side. Just say the number equals to and all that. So after that, entering the scores, you press A. Pressing AC means you are saving the data. What does this mean? It means that when you calculate A, B, and R, you'll not start from the beginning, because now we get A, continue to find B without starting from the beginning, because by pressing AC, you save the data. You'll see when we do that in the next one. Then you press Shift, you press 1, you press 5, you press 1, then you press equals to. The answer you get will be the value of A. Now, since we pressed AC to save, then if you want to calculate B, you don't start from the beginning. You press Shift, you press 1, you press 5, you press 2, then you get B. So then when you find R, you also don't start from the beginning. You press Shift, you press 1, you press 5, you press 3, then you get R. Now, normally, this A and B, you'll calculate them in the same question, because to find the equation you need A and B. So, and then R can be in a separate question. But when you calculate, just calculate three of them, then write this R somewhere, so that when that the question which needs the correlation on the strength of the correlation, you'll not start from the beginning, then you calculated R. So calculate all the three variables in one. Let's look into this worked example. A small business owner wants to establish whether advertising on public radio is effective. The table below shows the amount spent and the number of items. So obviously, like we're saying, as we did in the previous one, if you check this here, you'll first say mode, you say two. So obviously, if you press mode on your Casio and you press option 2, you press option 2 again, you'll get two columns. Then you in the first one is a 200 equals to 3,004. So 2,000 equals to, to enter it. 3,400 equals to 5,200 equals to. When you are done with the column on the left hand side, then you shift your cursor to the column on the right hand side, then take it up so that you start from the first one must be the first must be first on the column. So then you say 11,844 equals to 12,955 equals to, then you enter all of them. Then after that, as you said, you say AC. It means you're saving the data. Then you say shift, and then you say press option 1, then you press option 5, then you press option 1. Then the answer you get will be the value of A, if they say determine the equation of the least squares regression line. So then when you say equals to, the answer will be A, then you write it down. Then now to get B, you're doing the same thing. You say shift, press option 1, press 5, then you press 2. The answer you get to be the value of B. In this case, if you did it correctly, you'll get 0.46. Then you put it here. Then this will be the equation of the line of the best fit or the least squares regression line. Determine the correlation coefficient. Remember, as I said, calculate the three variables in one. So because you save the data, you don't have to start from the beginning. Then you will say shift again, 1, 5, then you press 3. So meaning A, it will be shift 1, 5, 1. To get B, it will be shift 1, 5, 2. To get R, it will be 1, 5, 3. Then in that case, you determine the correlation coefficient. Now, if you calculate it correctly, your correlation coefficient will be 0.57. If there's a comment on the correlation coefficient, because this number is very closer to 0.5, then we'll say there is a moderate positive correlation. It's moderate because the number is very closer to 0.5. It means that the plots are not very close to the line of the best fit or least squares regression line. Estimate the number of items sold if 15,000 is spent in advertisement. Now, if you check, They say estimate the number of items. Remember, number of items is the output, then it's y. It means you are calculating y. So it means now you just go to the equation of the least squares regression line, then substitute x, because this item sold is the input, is the x. Then it means you are substituted where x is. So it means the estimated number of items sold if 15,000 is spent in advertisement, then you substitute on X, then it means 17,744 items were sold. Now, if now they say estimate the amount which should be spent in advertisement for 22,576 items to be sold. First, we know that the number of items is Y. It's on the vertical axis. So it means now you'll substitute this one on Y, because now Y will be our output. Then it means here you are solving X. So it means you'll get 25,505 rand. It must be spent for 22,576 items to be sold. Worked example 2. Rate 8 results of 2 tests, each written out of 50 marks, are listed below. We see that we analyze the relationship between the performance of the learners in test A and test B. So our input, our horizontal axis would be the marks of the test A. The vertical will be the marks of test B. So now we're checking the relationship between test 1 and test 2. Use the diagram below to draw the scatter plot. Now, if you are given the graph paper, or if you are given the grid, you can use the grid to plot the points. So you can see that you'll plot, when you plot, you get something like this. Now, sometimes if you don't use the least squares regression line, one can be tempted to say this plot is an outlier. It will not be an outlier. It will depend on the least squares regression line. So you'll plot the point. You say that when x is, when the mark of the first test is 5, the marks of the second test is 24, and so on. If it's 31, 41, then you plot those points. The next question, remember the previous one here is a scatter plot. Means you have plotted, you have drawn what you call the scatter plot. So second question, determine the equation of the least squares regression line. So this equation will determine the least square regression line. So let's find the equation first. You know the method by using the calculator. You say mode, you press option 2, press up option 2, you enter the data scores, then on the left column, you put test A, and then on the end, you put, this is the marks of test B. Now, then after that, you press AC. By pressing AC, it means you're saving the data. AC, it means you're saving the data. So now to get A, you just say Shift, press option 1, press option 5, then press option 1. Then you get A. There it will be 25,48. So because you press AC to save the data. So to get B, you don't start from the beginning. You just start with Shift, option 1, option 5, then option 2. Then you will get A. As I said, for you not to start from the beginning, then just calculate R, even if not if it's not required in this question. You calculate R, then you write it somewhere so that you'll not start from the beginning when you calculate it. Then for R, you say shift 1 5, shift option 1, option 5, then option 3, then you'll get R. Then you'll write it somewhere, then you'll find it in the other questions. So this will be the equation of the least squares regression line, or the line of the best fit. From the scatter plot in question 1, to draw least squares regression line, or draw the line of the best fit. When you draw the line of the best fit, for you to know the gradient, for your gradient to be accurate, what you'll do, you will first determine what you call the mean point. Mean point is you find the mean or the average of test A. It means you're going to add all the marks of test A and get the total. Then you say how many there are. There are 10. Then you say the total divided by 10. Then that will be the mean mark of test 1. Then that would be the x coordinate. Now, then you get the mean mark of test B. You add all the marks of test B. You divide it by 10 because there are 10 learners through the test. Then you get something like 41,1. Then you can just plot. Here I plotted this mean point. So please don't. At the end, you don't really have to show that mean point. So at the end, now you see where there's a P here, is where I plotted my mean point. So this plot is not on the table that was given. It's a mean point. So this mean point will help me to draw the graph. From there, I check the y-intercept. If you check from the previous one, if you let x to be 0, y will be 25,48. Like here, if x is 0, y will be 25.8. Then this is the y-intercept. Then you put your ruler on the y-intercept and the mean point. Then you draw the line. Then the gradient will be correct. So it means the line must pass through there, must be from the y-intercept and the mean point. And please don't forget this. This is very important. Don't forget this. When you draw your least squares regression line, it should not touch the x-axis. So first, use a pencil. Remember, obviously, when you draw a graph, use a pencil. Use a pencil. Let it touch the x-axis with the y-axis, but it does not have to touch it. You just touch the x-axis, and it must pass through the mean point. And even this mean point, you'll wrap it at the end. So you'll erase it. So you put just for the gradient of the least squares regression line. So after that, if now your gradient is correct, where the line will be from the y-intercept, which is 25,48, and the mean point. Then you wrap that mean point, and then you erase the part of the line. The line must start from where the first point is, the lower limit is. Then it must end where the upper limit is. So now you wrap this. You in this one, you're just putting a line so that be correct. So, but you put the ruler on the y-intercept and the mean point. So, but at the end, this mean point will be erased. Then at the end, this part, the line touch the y axis, or the vertical axis. So at the end, your least squares regression line will be like this. So you can see that here I erased that mean point. But now, if you do this way, the gradient will be accurate. Then it will be exactly the way it's supposed to be. That's how to draw the least squares regression line. So you need to find the mean point. Mean point, you add all the inputs, get the total, then divide it by 10. And then then you do the same with the test B. You find the mean point. So you find the mean of test B, the mean or the average of test B by adding all the scores and divide by 10 because 10 learners do the test. Then you get the mean point, which is the X and the Y. Now, then, like I'm saying, you can just initially you can just put it here, put a dot here so that your line will be accurate. Then you put your ruler on the y-intercept, and then the line must start from the y-intercept and pass through the mean point, which will be erased. So I think you are just doing this form for the sake of getting the gradient correct. So then you erase that mean point. Then you make sure that your line does not touch the vertical axis. The line must start from the lower limit to the upper limit. The line must start from the lower limit to the upper limit. So you'll erase this part. So, and then the line will be like this. Then in this case, your gradient will be accurate. The gradient of the line will be accurate. Number 4, use the equation of the least squares regression line to predict a mark for the test B if the learner obtained 14 marks in test A. Obviously, now you are calculating the mark of test B, and you know that test B is the Y. Then it means you are finding the Y, then you know X, because you are given that mark of test A, which is the X. So it means you substitute 14 with this X, the answer will be the marks. It means if a learner got 14 in test A, we can predict that in test B, a learner will get 32. The next one, use the equation of the least squares regression line to predict regression line or the line of the best fit to predict a mark for test A if a learner obtained 29 marks in test B. You can see that here you are calculating the test A, which is X, then you're given the mark of test B, which is Y. Then it means you're just going to it means you are given you are given the mark of test B, which is Y. Then that's why you put 29 with this Y, then you are solving for X, then X would be 7. So it means that if you get 7 in test A, possibly look at 29 in test B. Remember, it's a predicted mark. But in this case, you don't just look at that and predict. You calculate using the equation of the least squares regression line or the line of the best fit. Identify the outlier. Now, if you look at this one, when you identify the outlier, you are not sure that so is this one, you are not sure is this one, and you are not sure is this one. So to determine the outlier, obviously you look at these points that can possibly be the outliers. So you'll check this one, and this one. Obviously, this cannot be an outlier. This cannot be an outlier. This cannot be an outlier. You can't say this is an outlier, this is not an outlier. So I think an outlier can be one of them. But now, we don't just have to guess. You must make sure that you get the correct one. One method can be this. We'll check the points where, the 3 points where which we can identify as the possible outlier. So what you can do to check which one is an outlier, you'll say, now you use the least squares regression line to determine the estimated mark of test B if test A is 35. The estimated mark will be 42,63 when you substitute X on the equation of the least squares regression line, then you'll get 42,63. Then it means this will be the estimated mark of test B. This is the actual mark of test B. Now look the difference, 48 minus 42, the difference is 5,37. We go to this one. When we substitute 44 on the equation of the least squares regression line, then you get 47,04. The difference, we say it means 47,04 is the estimated mark of test B if mark of test A is 44. Then you'll get 47,07. The difference is 7,63. So you go to the other one. The estimated mark of test B when test A, the mark of test A is 5, is 27,93. So it means this 27,93 is the estimated mark of test B when test A is 5. Then the actual mark of test B when test A is 5 is 24. Then you find the difference. The difference is 3,93. So out of the three, the one that has a greater difference is an outlier. So you can see that here the difference is 7,63. So it means the point where test A is 44 and test B is 40, it is an outlier because there's a greater difference between the estimated mark of test B and the actual mark of test B. So like I'm saying, the reason why, but if you are just given the table, there's no scatter plot, or what you can do, you can just find all of them. Say to substitute this mark on the equation of least regression line, then you get the estimated mark of test B when test A is 33, then the actual mark is 45, then the difference is 3,35. So you get all the difference. The one that will get a greater difference between the estimated mark of test B and the and the actual mark of test B, then that is an outlier. You can see in all the four, the only plot which has a difference between the estimated mark of test B and the actual mark of test B is where this one is this the coordinate where we have the plot where we have 44 and 40. Then when this point where test A is 44 and test B is 40, it is an outlier because there is a greater difference between the estimated mark, test B mark, and the actual test B mark, which is the 7,63. So that is why I will say 44 and 40 will be an outlier. Comment on the strength of correlation between test A and test B. I told you that when you calculate A and B, you must also calculate R and put it somewhere. And remember, you'll just say from the data you collected when you calculate A and B, then you'll say, or from the data you entered when you calculate test the value of A and B on the least squares regression line, or on the equation of the least squares regression line, then when you to get R, you'll just you're beginning, you'll say shift, press option 1, press option 5, and press option 3. Then you, so excuse me, the 0,79. Then if they say comment on the correlation, you say there is a strong positive correlation because you can clearly see that R is between 0,5 and 1. determine the percentage of the learners who performed within one standard deviation or between the first standard deviation. So in grade 11, you learned about this. And then if you are not familiar with this, you can just log in and then go to the revision of grade 11 data handling in my YouTube account. Then you'll find the clear the clear explanation of how to answer this question when they talk about the values falling within one standard deviation or or outside one standard deviation, greater than one standard or less than one standard deviation. So everything is explained in the video where grade 11 her data handling was revised. So you know that when you have this kind of question where they say determine the percentage of learners who performed within one standard deviation, the first thing is that you are going to calculate the mean and the standard deviation using a calculator. And then in that video, there's also steps of showing how to determine the mean and standard deviation. But now it's because now here you are only determining the percentage of learners who performed within one standard in test A. Then you're only going to use test A. Then you know that you will when you use the calculator, you will say you go to mode, you say then you say 2, then you say press, you go to option 1, then it will give you one table. Unlike the bivariate data, it will give you one because here this one is a univariate because you are dealing with one variable here, which is test A. Then you say mode, you say 2, you say 1, it will give you one column. It won't give you two columns because now this is invariate. So the difference that with bivariate, it would be mode 2, 2, but with invariate, you say mode 2, 1. Then it will give you one column, then you add the scores of 10, test A. So 39 equals to 33 equals to 35 equals to, then you do that in all the scores. Then after that, you say AC. You're saving the data so that when you calculate both standard deviation and mean, you don't start from the beginning. So then you'll say shift, then you say you press option 1, you press option 4, then when you press option 2, then you will get the mean. And you say option 2 equals to, you get the mean. Now to get the standard deviation, you don't start from the beginning because by pressing AC, you saved the data. So then you'll just say shift, then you say 1, then you say press option 4, then you press option 3, then you say equals to the answer you get will be the standard deviation. And as I said, when you answer this question, you'll have to find the interval of the lower limit and the upper limit. Lower limit will be mean minus standard deviation, which is 31,8 minus 10,44, then it will be 21,36. This will be the lower limit. Now, the upper limit would be mean plus standard deviation, which is 31,8 plus 10,44. Then the answer will be 42,2. Then deal with upper limit. So all the scores falling between the two limits or between the interval, then we'll say these are the scores falling within one standard deviation. So by we don't know percentage, then you say you check from the only scores that are falling outside the interval is the 5, and it's also the 44. The rest, they fall between 21,36 and 42,2. So it's only 2. So it means that 39, 33, 35, 37, 40, 24, 31, 30, and 30. they are falling within one or the first standard deviation. Because they are 8, then it's 8 out of 10, which is the 80%. It means 80% of the learners performed within one standard deviation in test A. That's how it's done. Now, notes and remarks. Greatness is like a roof. As the roof depends on strong foundation and strong structure. Greatness begins with consistent hard work, followed by success. By Khadile Mampolo, who is the man talking to you now. Thank you so much for viewing this lesson. And then we'll see each other in the next lesson. And please don't forget to subscribe. More videos will be uploaded. Thank you so much. Until we meet again.